Hello and welcome everyone to today's webinar on Macaron, a framework for software supply chain security analysis. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to dive into an overview of supply chain levels for software artifacts and its benefits, and to demo Macaron to analyze a project and its dependencies. We'll also be recording the session, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, please drop them in the Zoom chat and Q&A areas, and we'll be ready to help answer them. We've also set up a channel in our developer public Slack called Webinar Macaron that you can access at the QR code here or at bit.ly/odevrel_Slack. And we'll leave this channel open after the event to contact us directly if you have any questions, and to share resources and the recording in there as well. So today's webinar will be presented by Behnaz Hassan-Shahi, Principal Researcher at Oracle Labs in Development. So without further ado, I will hand it over to Behnaz.
Thanks, Tara. I'm very happy to be here talking about our project Macaron. I am the technical lead of this project, and basically Oracle Labs is the research arm of Oracle, where we do work in projects and new topics. In particular, our lab is focused on program analysis and building tools to test software. And in this particular project, we are focusing on supply chain security. Let's start with a motivation. Supply chain security attacks are becoming more and more prevalent. In particular, I want to highlight one attack in 2021 called code cover attack, where attackers were targeting a code coverage tool that is used by developers for testing purposes and to distribute malicious code. So the attackers had managed to steal credentials and upload an edited script that would then be directly distributed to end users and steal environment variables from their CI/CD pipelines and send them over to a remote server of the attackers. So let's take a look at the software supply chain diagram here, which comes from a framework called SLSA. SLSA is a standard for supply chain security that is developed by the open source security community. It stands for supply chain levels for software artifacts. And the idea is that by developing specifications and guidelines, we help developers to improve their CI/CD pipeline security and manage to generate and produce secure artifacts. So in this diagram, we can see that there are different points in a software supply chain that can be a target for attackers. And going back to the code cover attack, so for example, at point F, the attackers were trying to manipulate an artifact after it was built to distribute basically malicious code. So one solution that SLSA is proposing to prevent various types of attacks in this category is to generate provenances as part of the build process. A provenance is a verifiable metadata describing where, when, and how the software artifacts were produced by a pipeline. But before moving forward, I know that many people have heard about software supply chain security and SBOM, software bill of material, and they think that if they generate SBOM, that's good enough and they're good to go in terms of security. However, that is not quite right. So we need to first understand the problem a little bit better so that we can come up with the solution faster as well. So in this, for example, in the right-hand side, as you can see, there is a legitimate build pipeline, right? Where maybe you would say, yeah, so there is a step that calling a script called build to build an artifact as part of a CI/CD pipeline. However, if we look into the build script itself, all the script is doing is to download an already built artifact from somewhere and secure and distribute it. So even if we knew exactly originally what were the software components and dependencies that were going through our pipeline, still the integrity of our build pipeline is not guaranteed here. And at the end of the day, we will be potentially shipping malicious code to customers. So we really need to take a step back and think about our CI/CD services and see what is actually happening there. And in particular, we want to answer questions such as understanding where the source is coming from that is going through the pipeline and how that pipeline is dealing with that source code to generate a build, an artifact. So one of the goals of our project, and also many of the software supply chain security works that exist these days, is to establish a link between an artifact, not only to the repository where the artifact is coming from, but also the workflow and the exact build steps that had been used to create an artifact. And if we can achieve that, we are able to prevent various types of supply chain security attacks that we have seen in the past few years. And here we come to our project, Macaron, which is an analysis framework for supply chain security. So the goal in Macaron is to take the specifications that are developed in the community, such as SLSA, and convert them to concrete checks, and then use those checks to reason about the security posture of a CI/CD pipeline. So Macaron has two phases. In the first phase, we run our checks, and as part of that, we collect evidence and, for example, run static and dynamic analysis checks, analysis. And then we use, in the second phase, a policy engine to basically come up with a security requirement that can come from an organization compliance, and then say whether this artifact that was generated based on such evidence is trustworthy or not, and whether we accept it or not. So when we run Macaron as a verifier and a build platform that, for example, generates provenances verifiably, the way Macaron then works is that it determines what build tools are used in the CI/CD, what are the build configurations. It gathers the artifacts and the provenances associated with them, and then verifies whether the artifacts are built as expected or not. And some of the attacks that then Macaron could prevent is to make sure the artifacts are not generated from unexpected repositories, or, for example, in the case where an artifact is generated in an environment that an untrusted Docker image is used. Another example attack would be when an untrusted code from for example, GitHub repository is going to be built in Oracle, for example, or any other pipeline from any vendor, and the basically internal network, we would be able to capture cases when the untrusted code is trying to access overprivileged resources, or exfiltrate secrets, or and also another big concern these days, whether an insider threat has been trying to contaminate with the build pipelines and distribute artifacts without being discovered and identified. So as part of our project, we both provide the analysis framework, but we also encourage developers to improve their CI/CD pipelines and their supply chain by producing provenances. Here is one example where we contributed producing non-falsifiable provenances to Macaron projects, which is over 50 projects. And then Macaron now can be used to verify the artifacts that these projects are producing and to make sure they are built as expected. And this has led to improving the supply chain security posture of this project and being trusted more by the end users. But what happens if a project is not producing a provenance? Can Macaron still help? Yes. So Macaron is designed to come up with ways to track back an artifact to its origin using inference techniques as well. Even though we definitely prefer provenance first to be generated by the pipeline in a verifiable way. But if it is not possible, or some of your dependencies are not doing that, then Macaron, for example, has been shown to be very effective to trace back the artifacts to the origin. Here is some evaluation we've done on the 30 popular Java projects and their dependencies. So using the original metadata available as part of the configurations, like POM files and these projects, we were able to find 992 repositories. But with our inference techniques, we could increase that number by 45% and find a lot more basically mappings from the artifacts to the repositories. So Macaron is an open source project. Feel free to go to our GitHub repository and check the website. So there are lots of documentation on how to install it and how to use it. There is also a tutorial that today I'm going to talk you through and do it together. So let's jump into the demo. So for this demo, I have decided to pick a Java project that has two dependencies. One dependency is a legitimate dependency called Guava, which is from Google. It's in a good shape. It has automatic build pipelines. The artifacts are generated by GitHub Actions, and they are not basically produced manually by someone from their laptop. The other dependency is my own malicious Jackson data bind, which I'm pretending to be really awesome, and I'm convincing the end users to use it. However, the way I am distributing my artifact to basically stay unnoticed is that I go to Maven Central and upload it by myself after basically making some changes and pretending to be good on GitHub. So the final artifact that is uploaded to Maven Central is not actually what has been shown on the GitHub project. And this project, this malicious dependency, does not have a fully automated build pipeline, and that's why me, as a hypothetical attacker, could achieve that. By the way, all this is not actually a real malicious code, and it's just for demonstration purposes. So now let's see what we can do with Macaron. So Macaron is able to analyze a software component using different ways, including passing the repository path of the project. So in this particular case, my project is basically sitting in this repository, example Maven app. So all I need to do after downloading Macaron is to first run the analyze command and pass the path to the repository to analyze it. At this point, I can also provide the branch and commit to analyze a specific snapshot of the project. But right now, I'm happy with the default mode, which is the latest commit on the default branch. So now I'm running Macaron. It's going to first clone the project and then run the checks. Then it will try to determine the dependencies automatically. So after detecting them, it will run the checks on every dependency as well, and then produce an HTML report and a JSON report saying what has been discovered for this project. So if I, for example, go to the output, reports, GitHub, so the way we follow basically the convention of putting the reports under the specific repository Git service. So in this case, we are using GitHub, but we also support, for example, GitLab. So it's going to set under GitHub.com and then my GitHub space and then the name of the application. And then here you can see the reports for this particular run. Okay, so let's jump into the example Maven app HTML file, which is here. So this is basically the report that was generated by Macaron as the first phase and the analyze phase. And here you can see at the top, we have a table showing what checks have been running and what data and evidence was collected for this repository at this particular commit, right? So in this case, you can see that, well, you can see that the repository has a build service. It has some GitHub actions to do some testing, but it doesn't have a build as code, which means that it doesn't actually try to generate artifacts automatically from the pipeline. And then as we scroll down, we see that it has also found 2 dependencies for this project as expected. So the first one is my awesome Jackson database dependency, which is pretending to be awesome, but it is actually not. And then the Guava library. So let's click on these reports and see what is here. So apparently the Guava library that this project is using is version 32.1.2 -JRE. And then here we can see what checks have run for this particular dependency and what are the results. So apparently this library is in a really good shape. It has a fully automated build pipeline. In particular, I want to highlight this check that shows and pinpoints exactly what build or workflow run was used to basically publish this artifact. So if we click on this link, we see that Macaron has identified this particular GitHub action run that is generating this artifact. However, if now we go to the other dependency, which is my own version of Jackson database, we can see that Macaron has not identified any, corresponding CI/CD run for publishing this artifact, and it raises a flag that this might not be trusted. So at this point, we have collected some evidence about this project and the dependencies. So we reached the second phase of Macaron, which is to run the policy engine. So let's jump back to the terminal. So as Macaron runs the analyze command, by the way, all of these things that I'm describing here is in the tutorial. Maybe I go and show you in case you're interested to have a look. So under tutorials and the website. So this is basically the tutorial that I'm talking about if you are curious and want to go through it with me. Okay, let's go back again. The second phase, as I said, is that once we collect all the data, all of that will be stored in a local database here. So by default, the output directory is called output, and the database is Macaron DB. So now we want to run the verify policy command. And then what we need to do is to pass the database file, and also we need to pass a policy file. So here I have prepared a policy that will help us detect dependencies that are manually uploaded to Maven Central, for example, right? So it's called example Maven app. Okay, before running this, let's see how this policy looks like. So going back to my IDE, this is the policy that we are going to use for this tutorial. So Macaron uses datalog as the language for specifying a policy. You can think of it as like SQL. So you're going to write some queries to the database, and then your queries will intuitively be describing your security requirements. So in Macaron, we already provide some relations, datalog relations, to make it easy for you to write policies. So for example, here, relations like policy is component, and then transitive dependency, check path, apply policy, is report. These are all predefined policy relations that are coming from this preload datalog file. So I have provided a link in the tutorial in case you are interested to know how are these relations built and what does it mean. You can go there, have a look at the code. But what these relations are doing is that they are applying some rules and logic behind the scene to populate these relations, which can think of them as like tables, in case those rules and conditions are satisfied. So let's take an example. For example, we want to, in this particular case, find the transitive dependencies, right? That were discovered by Macaron. So in this particular relation, it recursively is going to determine all the dependencies and populate them into the transitive dependency relation. And then it will be used as the body of this relation that we're declaring here, which is violating dependencies. Okay, cool. So let's go back to this policy and really try to understand what it's doing here. So let's start from the bottom. So as I said, apply policy to is something you can just immediately call. And what you need to do is to first pick a name for your policy and say, I want to apply, this particular policy to these components. So in this particular case, I have a repository, right? I can put the full name of the repository here. And then this relation, the last column of this relation is giving me the component ID, which is nothing but a software component. It can be, for example, a jar file, a Python file, whatever artifacts we're using. So it will have a component ID in Macaron. So you say, okay, I want to apply this policy to all basically records of this particular GitHub project. So note that as we run Macaron again and again, for example, on this project, it is possible that it analyzes different commit versions of that project, right? So in this case, we will apply the policy on all the records of that repository. Then in the policy itself, let's see what's happening. So all we're interested in this particular case is to find dependencies that were uploaded manually by someone, and hence they can be malicious. So first, we want to declare a rule called violating dependencies. And what goes into this relation is what we think is a violating dependency, as the name says. So in this relation, we want to say, I want to go through all the transitive dependencies and then make sure that two checks pass. And the first check is MCN infer artifact pipeline 1, and the other check is provenance level 3. So now let's go back again to the HTML report to understand what these things mean. So when we run Macaron, if you remember, we had this table and we had the column here at the left-hand side with some check IDs. So each of these checks are available to the policy engine through the check, basically going back here, check passed relation. So all you need to do is to specify the name of that check here, and then you will be able to reason about the outcome of that check in your policy. So for example, to see whether it has passed or failed. For this particular security requirement, why am I saying both artifact pipeline and provenance level 3? What does that even mean? So remember earlier in my presentation, I talked about provenances. So if a project is generating a provenance and that provenance Macaron already runs a SLSA verifier on it and it makes sure it's valid, in that case, the provenance level 3, which is SLSA level 3, should pass. And if that passes, it means we have already a very good and robust link from the artifact to the CI/CD pipeline. But if that doesn't pass, then we run the inference, as we did here for the Guava project. So in the Guava project, if I again go back to that dependency, note that unfortunately it doesn't generate any provenances, so we have to infer whether there is a CI/CD pipeline that was actually producing this artifact. But if there was a provenance, we wouldn't need to do that, right? So yeah, here we are interested in the infer artifact pipeline check, and as you can see here, the provenance level 3 is failing, right? So going back to the rule, what the rule is saying is that a dependency is violating our policy if both of these checks fail at the same time. If one of them passes, it's good. But if both of them fail, it's not good. So we write this rule and we find dependencies that are violating our security requirement. And then here at the policy rule, we want to make sure that the relation violating dependencies is empty. That's why we put this negation at the front to make sure this relation does not have any dependency, right? So if this basically policy is satisfied, then we can report that our policy and security. So now let's go back to the terminal and run this policy. So as you can see, our policy has failed here. Why? Because we had one dependency, the Jackson data bind, one that was malicious, and it does not satisfy any of the rules that we saw here. So to that particular dependency, neither has a provenance nor has any CI/CD pipeline that shows transparently it was produced by here. So someone, being me from my laptop, have uploaded that artifact so that I cannot be discovered. So now let's take a look at another example project that actually generates a provenance. And that's, for example, Micronaut Core, which is a very popular framework that Oracle is also contributing to it a lot for building modern web applications. So if I run Micronaut Core, and basically if I run Macaron and Macaron.core, we want to see what comes back and whether like what checks are passing and whether we can write a policy to reason about it. So notice I'm doing something a little bit different for this project. So first of all, I'm not interested in this case in the dependencies. Let's say I have, in one case, all I want to know is to understand the security posture of one single dependency, here being Macaron.core, but I'm not interested in any of its own dependencies. So I can pass skip deps. And then I'm passing also an expectation called Q, Macaron.core Q. So what does that look like? And what does it mean to pass this Q file? So Q is a language that is a superset of JSON, and it can very easily specify what sorts of data I'm expecting in a provenance if it is generated, right? So for example, I want to make sure that all the Macaron.core artifacts are built from this GitHub project, github.com, Macaron.core projects, Macaron.core, and not an illegal fork, for example. They're coming from this particular tags, and they are produced by this GitHub action release.yaml. Right. So if I write this minimal expectation and pass it to Macaron, then Macaron will run a check, as we will see, to make sure the provenance meets our expectation. So let's now run this command. So similar to the previous example, Macaron is going to pull the, and clone the project and pull the relevant version. In this case, we are just saying it's find the latest commit and the default branch. And then here you see it's running the provenance level 3 check, and it has found provenances for this project. So it's going to take a while because this project has a lot of artifacts, and we are actually downloading them and we're verifying the signatures. So it can take like a minute or so. So before we don't need to really wait for that, and let's just jump back to the report that I had produced earlier. So in this case, Macaron.core is ticking a lot of boxes. In particular, you can see that the provenance level 3 is passing, and all these artifacts were verified, so we can actually trust and use them. And we know exactly where they're coming from. And also the expectation check that I just talked about is passing, meaning that it's exactly coming from that GitHub action that I'm expecting and from the right GitHub repo. So that's good. I can trust this application and this library, right? Now, if after the analysis has finished, then I can also go and write a data log policy. And in this policy, what I want to say is that always make sure for Macaron.core repository, both these checks are passing. First of all, I want to make sure there is a verifiable provenance. And also I want to make sure that the Q expectation check is passing as well. So whatever has happened during the build and captured in the provenance meets my expectation. So let's go again and run the policy. So if I run the policy as I showed earlier, so verify policy. Again, everything is stored in that local database. So it's going to be output MacaronDB. And then here the file will be policies Macaron.core data log. So now it's going to look at the data that was gathered for this project. And it says that the policy was passed. As you can see, there are 2 records because I had run this analysis before this project, and both of them are passing. Note that also in these reports that you're getting by the policy engine, it exactly shows you the package URL or PERL of this artifact, which in this case is saying it's coming from github.com, and this is the exact commit that was used for this analysis. I will also show you one more example without running this time. So this is another report that I had earlier generated for a project called SLSA verifier. And in this particular case, pretty much a lot of checks are passing, including checks such as trusted builder. So trusted builder is basically almost getting into level 4 of SLSA, and it is highly trusted because the build is actually running by some trusted, builders that are out of control of the maintainer. And this is one way that we are trying to solve a lot of supply chain security problems by limiting the number of trusted builders and make sure that those are used instead of ad hoc build scripts. That way, so we can minimize a lot of things that can go wrong. I think that's about it for the demo. And if there are no questions, I can go and continue my slides and wrap up. So I want to highlight that software supply chain security is not easy. It's hard. There are so many things going on. And one of our main goals in Project Macaron is to help the teams to slowly improve their security posture. So don't get scared. There are always steps to be taken one at a time, to ideally reach a point where we are fully trusting our build pipelines and we're fairly confident that the artifacts that we are shipping cannot be easily contaminated by attackers, as shown earlier in the code cov attack, right? So what's the first step? Let's start simple. Let's just make sure our builds pipelines are fully automated and it's not someone who is uploading these artifacts haphazardly from a laptop, right? Like I did for my malicious dependency. Second, we want to take a step further and generate provenances as we are building. There are existing tools. For example, on GitHub, there is a project called SLSA GitHub generator. They have various trusted builders for different ecosystems like Java, Go, and also they have some generic generators that work for any type of code base like Docker container, etc. So go have a look and try to generate provenances that way. Another tool is called Witness that Macaron also supports. Witness also helps you to generate provenances during your build pipelines, and then you can use Macaron to verify them. So once we generate these provenances, then we want to go deeper and say, okay, now is my build hermetic as well? What does that mean? So I want to block any, for example, network connection as I'm building my artifact. Is my build reproducible? If I run this build again, will I get exact same artifact? That way I can tell if someone replaces my artifact with a malicious one, hey, like these, because I cannot, when I reproduce, they don't match, then it could be malicious. So, but this is quite hard to achieve. So it's not something that I would suggest to do in the first place. But maybe one day we can get there as well. And in conclusion, we want to harden our build pipelines and use Macaron as a verifier to improve our software supply chain security posture. And when, however, it is not possible for a dependency, let's say, to find any provenance because it will take time for open source community to accept and adopt these best practices, Macaron will run its checks to infer security properties and track back artifacts to their origins, as well as running other tools like OSCS or other vulnerability detection tools as part of its checks to understand, okay, is the dependency that I'm actually ingesting and using in a good shape or not? So try Macaron on both your own build pipelines, or if you're just interested in some open source dependencies from public registries. We right now support Java projects, whether basically they are built with Gradle or Maven. We support Python as well, but the dependency resolution in Python is a work in progress. We also support Docker containers as a build tool. Yeah, and support for other languages are in the pipeline and are going to be available really soon. So have an eye on our releases. We do have very frequent releases, and we keep adding features almost every week to this project. And we are very excited about it. We would love to hear your feedback. So yeah, please do try it and let us know how it goes.
Thank you all again so much, and we hope to see you at the next one.
Thank you.